Thank you, Apostole, and also thanks SQE for putting once again this successful forum together and giving us the opportunity to talk to you, dear colleagues. Good afternoon. Even though the IMO Convention has not been voted yet, having dealt with this problem yesterday would have been too late. We're going to go through some critical elements related to the design, the selection, and the installation of ballast water treatment systems. The process is the quadric modal process. We start with a selection and a design study to be followed by the detailed study and installation. But a lot of challenges will be confronted in the process. What is critical is what lies below the iceberg, below the surface. Putting the days and the ships one by one, by simple math, we can find out that had the convention being validated tomorrow, we would need to do 40 to 50 retrofits every day from tomorrow till the end of 2017. Having that number in mind, it seems to me that we should not overemphasize the selection process. It appears that we might have a makers selling bonanza or a first come, first served event. Unfortunately, we do not have feedback from ballast water treatment systems. It seems that we are dealing, unfortunately, with a case of public pressure putting the regulations ahead of technology. We can apply advanced selection techniques like fuzzy logic or multi-criteria decision analysis, or even simpler statistical grading of a series of questions which can be grouped related to technical, health and safety considerations, financial, operation, installation and maintenance considerations. But the $1 million question is, are we going to have the time to go through this grading and selection process? The installation questions we have is where to place the system, how to integrate it with the remaining machinery, and what to do. Well, we have to forget the 3 to 4 weeks typical approval time from class. This is going to be a much more involved process. Remember that we are going to have to submit not only the usual piping drawings, but also structural and electrical and control automation drawings. We might employ 3D laser scanning technique in order to curtail the time needed instead of the usual survey and hand metrics. Utilizing laser beams which sample at a pace of 1 million points per second, we can have significant savings in time, half a day survey. We might create point clouds on which we can superimpose the system to be constructed. Of course, the whole process from A to Z can last anywhere from 9 to 18 months until commissioning. Depends on availability of resources and experience. Remember that having a fleet, you might strike a bargain with the makers. Another question you have to ask is, what will happen to me, what will happen to my trade prospects if we do not install a ballast water treatment system in a specific vessel? Well, allow me to show the inevitable differential equation that shows that the effectiveness of a ballast treatment system is exponential function of the concentration of the killing agent and the time of exposure. Somebody has to know the limits of the system, has to know how the effectiveness of the ballast water treatment system is affected by temperature and salinity, by the size of the installation, how many cubic meters per hour we can treat, space available, if we have to take care of post-treatment contamination and do the treatment during deballasting, as well as management of dangerous gases produced during the treatment process, and the availability of explosion-proof versions, which might be necessary. We need to do a hydraulic analysis in order to determine if there is a need for boosting, for booster pumps. An important element of the system is the filter, can be mechanical type, screen or disc types, hydraulic, like hydrocyclones, and a lot of times we have to resort to back-flushing, back-washing in order to reduce the pressure drop through the system. But remember that when you do back-washing, you reduce your ballast flow rate. What we have to avoid in filters, filters are suffering from clogging, corrosion, mechanical failures, lack of spares, and of course, remember, potential for hydraulic hammer because of sudden blockage of the flow area. The installation in tankers can be a problem, can be a challenge. Why is that? Because if the system is not installed in a hazardous area like the pump room, then it becomes the link that will connect a safe area with a hazardous area. As a golden rule, everything that is installed in a hazardous area must be explosion-proof and must be categorized, must follow the apparatus and the temperature group standards. It is nice and convenient to install the system in the engine room. This can be done provided that we send the ballast water in the open deck, and then from the open deck we penetrate the ballast tanks. We need to make everything that is installed in a hazardous area needs to become intrinsically safe, explosion-proof. This is not necessary for something that is installed in the engine room. For example, one of the solutions is to install the treatment system on deck. But if we install it on deck, because of the head from the pump to the deck, we need to be careful of the possibility of having a vacuum. We need to possibly install a vacuum breaker. The after-peak tank is a safe area. The problem with the after-peak is solved either by the draconian solution having a second system for the after-peak, or by going the usual recipe, open deck, and then through non-return valves, go to the ballast tank. Another solution, notice that the pump is in a safe area, can be to connect the after-peak tank with spectacle flange. Also, we can go from the safe storage area in the engine room, we can go to the ballast pump to put various chemicals, provided that we follow a quartet of safety measures, like reverse flow sensor, fail-safe control valve, a loop seal, and a check valve. Another challenge is sampling, as all of us know. Sampling must be done as a kinetic sampling from an area of well-mixed flow and uniform flow. Isokinetic means that the flow in the ballast pipe and the flow, the velocity, in the sampling pipe are the same, are equal. Turbulence helps the mixing of species, the mixing in the flow. So sometimes we help turbulence by putting a mesh screen upstream of the sampling pipe, whose diameter is about 10% of the ballast pipe diameter. Now, the problem of time for testing and sampling can be solved with what we call flow cytometry. Flow cytometry is a biophysical process of sorting and cell counting. And this biomarker, widely used, is not something new, is clinical applications and biochemistry, can be utilized, can send automatically data via satellite, and by the time the ship comes to port, it has a certificate of clean bill of health for the ballast water. It's very important. No time for sampling and testing, very critical. This is a very promising technique. But standing in front of you today, I have two questions in my mind. What happened to corrosion protection and PSPC? What happened to the need to reduce the carbon dioxide footprint? It seems that maybe we have to resort, as previous speakers discussed, to the global conveyor currents, local and global. Or maybe we should apply operational measures for this problem, like do the ballasting in the right place, the right time. If we can, because of course, remember that ballasting is connected to loading and unloading. They are parallel operations. I hope that you will agree with me that the only thing we want to kill are these tasty Alaskan king crabs. Finishing, I would like to say that it is a fact of life that everybody wants to be on the high side of the boat. Pioneers, though, or no pioneers, all of us that work in shipping, we have to remember that we are all boiling in the same pot and we are all riding the same boat. Thank you.